Okay, so the purpose of this video is to go over the chain rule, and your goal is to evaluate derivatives of composite functions both algebraically, graphically, and numerically. For the purpose of these first few videos, we are going to be focusing on evaluating derivatives of functions algebraically. So we're going to be right here. Later on, we'll talk about graphically, numerically. So first of all, what is a composite function? This is a review from pre-calc. A composite function is simply made of a function inside of another function. So back in the day, you may have been given something like this and then asked to compose f of g of x. The outer function being the square root and the inner function then becoming x squared plus 3. So you might have gathered that h of x would equal the square root of x squared plus 3. And if you can tell here, you've got a function, x squared plus 3, inside of another function, which is the square root of x. For the purpose of what we're doing, it's going to become important that you understand which one is the inside and which one is the outside. Clearly, the outside being the square root, the inside being the x squared plus 3. In a second example here, I've already composed it, and so you see cosine squared of 4x minus 1. Now this may not look like it, but this is actually a function inside of a function inside of a function. Let me rewrite it so you can see a little bit better what I mean. So I'll start with cosine of 4x minus 1. And what you're going to see is this squared that goes here. What it really means is you take that entire function and you square it. So if you go to the very inside function here is a 4x minus 1, which is inside of a cosine, which is inside of a power squared. Okay, so in this case, we have a composition where we have 3 layers. The very inside, the next one, and then the last one. Okay, so that's really a composition of functions inside of functions. So the goal is going to be to take derivatives of things that look like this. So the question is, how do I take the derivative of a composite function? Well, there's something called the chain rule, and the chain rule is also known as the inside-outside rule, because this is how it works. It says that if you have a function h of x, which is a composite function, f of g of x. Notice g is inside, f is outside. Then the derivative is simply going to be the derivative of the outside, leaving the inside alone, and I'm missing a parenthesis here, times the derivative of the inside. Okay, so it's the derivative of the outside, leaving the inside alone, times the derivative of the inside. I try to write it out for you. This would be a good thing to put in your notes, but the derivative of h of x, given that it is a composite, would simply be, I'll put this in parentheses, to take the derivative of the outside leaving the inside alone, and you're going to multiply that by the derivative of the inside. Okay, so let's go ahead and do some examples. I kept all that stuff here, pretty important. This is kind of the official rule, and this is going to be our in words so we can better understand that rule. Here we go. I have an example. H of x equals cosine of 3x squared minus 5. Again, the goal is to take the derivative of a composite function. We're going to use the chain rule. But first, let's identify the inside and the outside. So here you can see that the inside, right here, is made out of 3x squared minus 5, while the outside is cosine. Okay? So to take the derivative, I'm simply going to follow the rule. I'm going to take the derivative of the outer function, which is the cosine. And I'm just going to leave everything else alone. So if this were simply cosine of x, if there were not this complicated 3x squared minus 5 inside, if it were just cosine of x, the derivative of cosine, you guessed it, would be negative sine. So I am taking the derivative of the cosine, which is negative sine. And I need to leave the inside alone. So I will copy the inside and leave it alone. I will not change it at all. That's step 1. Okay, so I took the derivative of the cosine, but I left the inside of the cosine alone. And I'm going to multiply it now by the derivative of the inside. So now I go in here and I focus on the inside and I take the derivative using power rule. You will note that it is simply 6x. The 5 becomes 0 and I'm done. Technically, this is your derivative. Done. Derivative of the outside, leaving the inside alone, times the derivative of the inside. That is the derivative of this function. If this were a multiple choice test, they will more than likely bring that 6x to the front, which is totally legal through the commutative property. And you would more than likely see it like this. You can't really distribute because this is a sine function. It's being multiplied. And so you're done. That's it. Example 1 done. Let me set everything up to do example 2. So example 2, I have here a polynomial function. I notice I have 5x squared minus 2x being raised to the 4th power. Again, you have to identify what's the inside, what's the outside. While the inside clearly is this 5x squared minus 2x, and it's all being raised to this 4th power, which becomes the outside function. So the 4th power, that's my outside. This 5x squared minus 2x is the inside. So to take the derivative, I'm going to follow the rule. And I'm going to take the derivative of the outside. I'm going to pretend like this was just x to the 4th power. If this were x to the 4th power, by the power rule, I would bring my power to the front. So that would be 4. And then I would subtract 1 from the actual power, making it a 3. So I've taken the derivative of the outside. Leaving the inside alone means I simply copy what was inside without changing it at all. Okay, so I've done this part. Now I have to multiply by the derivative of the inside. Well, the inside is 5x squared minus 2x, so the derivative is going to be 10x minus 2. But because it's a two-term polynomial here, you need to actually use parentheses so that everything gets multiplied, not just the 10x. So that's it. We're done. We took the derivative of the outside. That's why we got a 4 here. We subtracted 1 from the power, left the inside alone, and then multiplied by the derivative of the inside. If this is a multiple choice test, more than likely you might see this 10x minus 2 brought to the front, and they might even distribute that 4 in there. So it might look something like this. This is one option. You do not have to go through these steps, but again, if it's multiple choice, they might actually go through and do this. And then 5x squared minus 2x all to the 3rd power. So basically, you have 3 different versions of the same thing. What's important here is you're understanding this part right here. The derivative of the outside, leaving the inside alone, times the derivative of the inside. Okay? All right, let me set up and do another example. Okay, so I've set up here another example, this time with a square root. Again, if you identify, we have a function, x squared plus 3, inside of another function, which is the square root of x. And this is actually that first function we saw when I introduced composite functions. And so we're going to go ahead and take the derivative. Again, the outside being the square root, the inside being the x squared plus 3. So we're going to follow the rule. The derivative of the outside. So this is the same as x squared plus 3 all raised to the 1/2 power. So if this were just x, we would take, for the derivative, we would do the power rule. So we would drop the power and subtract 1. So that would give us 1/2. And then up here, it would be negative 1/2 because 1/2 minus 1 is negative 1/2. So that's the derivative of the outside, leaving the inside alone. So that means I have to copy everything that was inside exactly the way it is. Common mistake is for students to take the derivative here, which is not okay because you're supposed to leave the inside alone. And then you multiply by the derivative of the inside, which in this case is simply 2x. And that's it. derivative of the outside, leave the inside alone, then multiply by the derivative of the inside. So common mistakes are to take the derivative here, which you're not supposed to, you're supposed to leave it alone, or to forget to take the derivative of the inside and not multiply that at the end. So those are two common mistakes. What you see is this is a good answer, but you probably won't see it like this on a multiple choice exam. More than likely what they'll do is they'll drop this to the bottom so that the power is positive, and then the 2 will reduce with the 2, leaving you with this is probably what you would see as a choice instead of this long version. Okay? All right, I have one more that I want to show you, and let me go ahead and set that up. Okay. This one seems to be tricky because of the way that it is set up. Trigonometric functions generally have their power set up right here. What this really means, and I always encourage my students to rewrite it so you can get a better visual. This really means, it doesn't mean take the sine of x squared. It means take the sine of x and then square the entire function. That's what it truly means. And I always encourage my students to rewrite it so you can definitely see the difference. It's easier to see. So clearly here the outside function is the power, the inside function is the sine. So following the rule, we will take the derivative of the outside, which means drop the power and subtract 1. So that would give me 2 to the power of 1. Leave the inside alone. So sine of x. And now multiply by the derivative of the inside. The inside is sine of x. Its derivative is cosine of x. So that gives me 2 sine of x, it's just to the 1 power, so I don't really need to write the power, times cosine of x. And that's what you would see on a multiple choice exam. Okay? As I was working this problem, I thought about showing you a separate example so you can see the difference. So this was sine squared of x. What if the problem were sine of x squared? Okay, in this case, what you are squaring is the x, which is already the inside term, versus this example where you were squaring the entire sine. So you really need to see the difference of where we place that 2 makes a world of difference. In this case, the outside function is now the sine, while the inside is the x squared. So to do its derivative, we would simply take the derivative of the outside, which in this case is cosine, leaving the inside alone. I always kind of say the chant in my head as I work it out, times the derivative of the inside. Derivative of the outside, leave the inside alone, times the derivative of the inside. And of course, on a multiple choice, they would bring that 2x to the front just to make it look pretty, and there it is. Hopefully this made sense. There's about 4 or 5 problems that I'm going to include so that you can practice, and we'll go over the answers real quickly tomorrow. So good luck. Let me know if you have questions.